Good morning everyone. Today I discuss about the application of Karl Pearson theory. A question come in your university exam. Explain Karl Pearson theory or write down the short notes on Karl Pearson theory. Second type question, explain product movement method of computing coefficient of correlation. So how will you calculate or how will you compute the coefficient of correlation? This method is invented by Karl Pearson, name of the scientist, and he gave the method for the computing of coefficient of correlation as below, and this is symbolically represented by the symbol small r. So, the calculation of a small r from undergroup data, the basic formula of computation of a small r for the undergroup data by this method is r is equal to summation of sigma xy by root over summation of sigma x square multiplied by summation of sigma y square, where x and y represent the deviation of a score in the test capital X and capital Y from the means of each distribution. So, the procedure for calculation of R by this formula can be understood by the following example. Here we can give the one example. Suppose individual score of a students is A, B, C, D and E, and their score in this subject, any subject, is 15, 25, 20, 30, 35. In another subject, the score of the students is 60, 70, 40, 50 and 30. Now, the mean of this score is written here by the value of x. X is equal to minus 10, 0, minus 5, plus 5, minus 10. And the value of y is equal to 10, 20, minus 10, 0 and plus 20. So, after multiplication of x and y, we got the value of xy. Xy is equal to minus 100 for the case of A. For the case of B, the value of xy is equal to 0. For the case of C, xy is equal to 50. For the case of D, xy is equal to 0. And for the case of E, xy is equal to minus 200. After computation, summation of xy is equal to minus 250, and the value of x square is equal to 100, 0, 25, 25 and 100. On computation of this value, you can got the value of summation of sigma x square is equal to 250, and the value of y square is equal to 100, 400, 100 plus 0 plus 400. Then you can got the value summation of sigma y square is equal to 1000. Now, by applying the Karl Pearson theory of formula, r is equal to summation of xy by root over summation of x square multiplied by summation of y square. So, you can put the value of summation of sigma xy, that is minus 250, and root over summation of sigma x square, that is plus 250, and summation of sigma y square is equal to 1000. Now, after calculation of this value, you can got the value minus 250 by root over 2540. On the calculation or removing the value of root, you can finally got the value of minus 250 by 500. So, minus 250 by 500 is equal to minus 1 by 2 is equal to minus 0.5. So through this method you can calculate the value of by the using of Karl Pearson theory. Now come to the main point. What is Karl Pearson coefficient of correlation? So it is the most widely used method of measuring the degree of relationship between two variables. This coefficient assumes the following. First, that there is linear relationship between the two variables. Suppose you can take an example, x and y is the two variables. If you can increase the value of x, then the value of y is constant. Then you can got the value of linear relationship between the x and y. The second assumption that the two variables are causally related, which means that one of the variable is independent and the other one is dependent. And third assumption is a large number of independent causes and operating in both variables so as to produce a normal distribution. Thus, the Karl Pearson coefficient of correlation can be worked out. So, symbolically, we write down the Karl Pearson coefficient of correlation by the symbol R is equal to summation of sigma under bracket xi minus x bar multiplied by yi minus y bar by n multiplied by sigma x multiplied by sigma y. This is the method. This is the Karl Pearson method, where the value of xi is equal to ith value of x variable. X bar means arithmetic mean of x. Yi is equal to ith value of y variable, and y bar is equal to mean of y, that is the arithmetic mean of y. Whereas the value of a small n is equal to number of pairs of observation of x and y. Here given that as an example, A, B, C, D, E, the name of the students, the number of variables is or number of pairs is 5. So you can put the value of n is equal to 5. Summation of sigma x is equal to a standard deviation of x. Sigma y is equal to a standard deviation of y. So in the case we assumed mean ax and ay for variable x and y respectively in place of true mean. Then the Karl Pearson formula is reduced as r is equal to summation of sigma dxi multiplied by dyi by n minus under bracket summation of sigma dxi multiplied by summation of sigma dyi by n but a root over summation of sigma dxi square by n minus under bracket summation of sigma dxi by n का whole square multiplied by for y variable root over summation of sigma di square by n minus summation of sigma dyi by n का whole square. Whereas summation of sigma dxi is equal to summation of xi minus ax. Summation of sigma dyi is equal to sigma under bracket yi minus ay. Here is given the as usual value, and summation of sigma dxi square is equal to summation of xi minus ax का whole square. Similarly, for summation of sigma dyi square is equal to summation of yi minus ay. Here n is equal to number of pairs of observation of x and y. So, Karl Pearson coefficient of correlation is also known as the product moment correlation coefficient, and the value of R lies between the value of plus minus 1. The positive value of R indicates the positive correlation between the two variables. Change in both variables take place in a statement direction, whereas negative value of R indicate the negative correlation, that is, changes in the two variables taking place in opposite direction. But in the case of zero value of R indicate that there is no association between the two variables, between the x and y, whereas the value of R is equal to positive indicate perfect positive correlation, right? When its value is negative indicates perfect negative correlation, meaning thereby that variation is independent variable of x. So, explain 100% of variable or 100% of the variation in the dependent variable y. So, we can also say that for a unit change in independent variable, if there happens to be a constant change in the independent variable in the same direction, then correlation will be termed as perfect positive. Right? Any questions? Any doubt? No. Okay. Thank you. Thank you, everyone.